You know, when you're talking about fatigue, you talk about a high amount of loads. So you would not be able to calculate the stress value for each and every one of this load case. You would be able, but it would take forever. So rather than doing that, you would do a calculation of static load cases, which are more like unit load cases, you could say, and then scale depending on the value which is used here in the time histories, right? So you get a relationship between force and stress for each element in static load cases. Hey guys, welcome to this video. Today we're gonna take a look at a new topic, fatigue analysis. I'm a hell of a lot thrilled about this because I'm not that an expert of fatigue analysis, but I want to get into the topic a little bit more deeper. And I will just use this chance of learning the new Hyperworks layout together with this tutorial. So fatigue analysis. Now, before we start, I want to just point out something to you which came up as I was first recording this tutorial. So what are we talking about? So you see that you go into the Optistruct tutorials and then you will see this OS-HWX-T 6010 fatigue process manager using SN method. So we will be using this one. This will require you later to have a file called load2.csv file, which is not as a link in here. So you cannot access it. Then I asked Jan at Altair what to do about it, and he pointed me to the community webpage, community.altair.com/community, and then you will find a link here to the documentation, and this is this file browser, you could say, and there you can also scope for tutorials. And he suggested to me that I would use not the latest one, but rather the 2021.2. And if you now just also scope for Optistruct, then you are left with the tutorial models here. Because those tutorial models are, in opposite to the newest one, those are not sorted depending on tutorial. So, and you will get a zip file which looks like this, and then here you have the load2.csv file. So yeah, to summarize it, just look in the tutorial files one below, and this is a good resource for getting this if you don't have the tutorial files installed locally from a previous version, which is maybe also unlikely, right? Okay, now this is out of the way, so we want to dive into here. First, tiers. This will be a longer ride, I think. Yeah, so disclaimer once again. I'm not a fatigue expert. And so you have to take this with a grain of salt, what I say regarding to fatigue, because I have not that much of an experience still, but I'm learning. So we have now the stress life method. So this N is this refers to the number of cycles, I guess. N is just number of cycles. So the SN approach for calculating fatigue life. SN approach is suitable for high cycle fatigue. All right, what is high cycle? This should be load cycle, right? And this is also displayed here in the diagram. So you'll see this is some like a fatigue curve, you could say. And on the y-axis you have the stress amount, and on the x-axis you have the number of cycles until it breaks. When does it break? When it hits the line here. So this is a material characteristic which you can find or not find or pay money to do it. So this is some data which is most likely done with testing. So you could just see a tensile test with fatigue loading. So it does like this all the time. And it does this on various loadings. And it does that for some amount of time. Sometime it will break or it will not break. Then you will just abort it after 10 to the power of 6 cycles. You will say that's fatigue, all right? Or fatigue safe, I think it's a term. Yeah, so, and you see that there is low case or low cycle fatigue and high what is cycle? Yeah, look, low cycle and high cycle fatigue. So, and the magic boundary here is 10 to the power of 3. All right, so below that, low cycle, bigger than that, high cycle. That also depends on what you're really having, right? So that depends on what loadings you have on your part and stuff like that. So, all right, but this is it. Now we start with just getting the file here, and I will just load this file into Hypermesh directly, or Hyperworks I should say. And I enabled my green screen so you can see the full beauty of Hypermesh here in the background, hopefully. But we will be using as less panels as possible. So this will be the case here. All right, first error, invalid file name. So that means we would have to first export that from the zip file and then drag it in. This works better. Okay, now we have the file in and we can just look at it a little bit. All right, so this is just the control arm in a slightly changed way, I would say. So, see also a little bit of a 2D elements here. All right. Just wait a second. All right. So, sorry about that. Yeah, we have that one, and back to the tutorial. So we have learned what a high cycle and low cycle fatigue is and the fatigue limit, and now you would have to define a material curve for that one. So let's also read about this. Since the stress life theory deals with uniaxial stress, the stress components need to be resolved into one combined value for each calculation point at each time step and then used as equivalent nominal stress applied on the SN curve. Yeah, so as you saw, the y-axis is just one axis and you would have to determine one singular value. So for a tensile test, that would be the uniaxial stress, right? So, and in this case, maybe you would want to match that with a linear combination of different stress directions, but the endpoint is the same. You would end up with one singular value, which you can then apply to your fatigue curve and see how many cycles it can withstand until breaking, right? So in Optistruct, various stress combination types are available, with the default being absolute maximum principal stress. Okay, so for each element you could go and just say, all right, I want to have the maximum principal stress, but in absolute terms. That means that also compressive stress would get considered. So if you have a higher compressive stress, which would be negative, it would count as the value to put in here. But I think that's not always the case. In general, absolute maximum principal stress is recommended for brittle materials. Okay, while sign from mesos is recommended for ductile materials. So if it's ductile, you should rather use sign from mesos, and sign from mesos, in this case, if you do a max, the compressive stresses will just not be taken into account, I guess. All right, the sign on the signed parameters is taken from the sign of the maximum absolute principal value. Yeah, okay. In this tutorial, you will be able to evaluate fatigue life with the stress life method through process manager step by step. Yeah, so the case is that you would have to set up a lot of cards, and the process manager helps you a little bit with that. And bear in mind, there exists also Hyperlife, which also does this even more, I would say. But I have not tried that out yet, maybe in the future. Okay, so now the part. A control arm is loaded by brake force and vertical force is used as shown in figure 3. Okay, you have two different kind of forces. Two load time histories acquired for 2500 seconds with 1 HZ shown in figure 4 and 5 are applied. The material of the control arm is aluminum whose stress life curve is shown in figure 6. Because a crack always initiates from the surface, a skin meshed with shell elements is designed to cover the solid elements, which can improve the accuracy of the calculation as well. Alright, so this is the case. Let's back up a little bit here and take a sip and talk a little bit about it. So you see that you would have two forces, two load cases, and those would be, I would say, static load cases. You know, when you're talking about fatigue, you talk about a high amount of loads. So you would not be able to calculate the stress value for each and every one of this load case. You would be able, but it would take forever. So rather than doing that, you would do a calculation of static load cases, which are more like unit load cases, you could say, and then scale depending on the value which is used here in the time histories, right? So you get a relationship between force and stress for each element in static load cases. And then you sum up your damages over the time histories here by scaling the stress values gotten from the static load cases onto the time history series and then accumulating. And accumulating also is a whole bunch of topic for itself, because you would not be just go from every point to the next point and get the delta and then just do something with that. You would rather do something like the rainflow method, where you just find the pairs which are really damaging your part. But this is a topic for another video, or even multiple videos, how the rainflow method works, how you could program that. But for our benefit, it's already done in HyperMesh or Hyperworks itself. So you could use the rainflow method even without having programmed that to the point. Okay, now we have a material curve, we have our stress patterns, loading patterns here for the time history series for both forces, vertical and braking. And now we get into the details. So I will just put that down here for a second and we'll just walk you through. So we launched that, we imported that, we have a template ribbon, which is there. Am I blind again? No, there's no template ribbon. From the template ribbon, select the Analyze menu and select Fatigue. Am I in the wrong profile? Always a beginner mistake. No, I'm in Optistruct, so then I will go... Either I'm totally blind. What could that be? So that's the right version. Analyze, and then here template, and then Fatigue Process Manager. All right, I'm here. Now I would enter here my session name. Okay. Yeah, let's go with the standard working folder. Click create, creates this process manager. I think this should be just a bunch of XML files which just record what I'm doing here in the process manager. But I could be wrong. Now, I imported the model. I did that, right? Make sure the task import files is selected in the Fatigue. Yeah. Yeah. There should be this process manager. Yeah. And here you can see import file. Yeah, this is active. Then select the control arm. Simply walk back here. Yep. Okay. Then I hit import and apply. Then I'm on the next one, and here this will be create a new fatigue subcase. So make sure the task fatigue, yeah, this is done. In the create new fatigue subcase field, enter fat sub fpm tut. Okay, so that means fatigue subprocess and fatigue process manager tutorial, I guess. Okay, we create that. We have it automatically selected. And yeah, this is selected. Optionally, you can choose to create all fatigue solver cards in separate include files. For this, you should select the checkbox create include file for fatigue solver cards. Yeah, should we do that or shouldn't we do that? We will not do that. All right, we click on apply. So this is done. And now we go to the fatigue analysis parameters. Now here you're setting up your fatigue analysis, or more or less the properties of it. So we have a method of uniaxial. Is that correct? I think so, yeah. It should be the sign for Mises, I guess, because we're using aluminum. Then we have units MPa and the mean stress correction. That could be, what should we do? Gelber. All right. We select that, and then for rainflow type, this is also possible to just use the rainflow for loads instead of stress, but we will go for stress. Uncertainty of survival is 0.5 and gate is 0. Okay. Hit apply. This is done. Now, add fatigue elements and materials. Now, this is a tricky point, I remember, because the curve got not accepted a few times, so. Yeah, bear with me. So I will try to do it exactly like the tutorial. So add material. All right. For material name, select aluminum. Okay, that's already done. Stress units MPa. Okay, and then we will enter 600 under ultimate tensile strength. Now click SN curve material properties. It's not selectable. Maybe I have to check it here. Yeah, check it and then I can press it. Now, estimate from UTS. Material type aluminum alloys. That's all right. Now I will be entering the data like it's given in the tutorial. 2273.68 minus 0.107176. 5 to the power of 8. Okay. 0 and 0.3 is correct. Then one slope, 0.15 and R. That's all right. Okay. Okay. Now, show curve definition. Oh no. Okay, I could just hit estimate. This would be the same thing. Okay. I could hit here and then I would get the values also as a plot. Yeah. See? It's gone. Why? Why is it gone? Okay, once more. 600. I have this curve. I click here. I will go to estimate from UTS. I will click on estimate. I will click OK. Plot SN curve. All right, now I can see it. And that's all fine. I picked the wrong one, right? What? This is correct. Aluminum is correct. All the values are correct. Okay, I just hit save now. Hopefully that worked. Now I should click on add property. All right, P shell, that's okay. Property name should be shell. Strange name for property name, okay. Create. Okay. I click create to create pfat property. This probably is a property file for the fatigue analysis. So here I can choose from which layer I want to have the stress outputted, for example. So in this case, for layer, it wants me to select top. Ah, yeah. I know what that is. And this is about finishing of your surface and other factors which would require a change in the fatigue operation, or fatigue calculation, I should say. So for example, coatings, or if you just hit it with those little spheres, it's called, let me see, finish, polished, machined, hot rolled, ground, treatment, yeah, shot pen, yeah, shot peen, cold roll. Yeah, you could get factors which are yeah, just changing your fatigue performance based on treatment and finishing. So, but in this case we will have none as both. And also if you have another thing just which is not available here, you could also click here and just give the factor. Yeah, so this is the thing. Then if you have additional factors which are not implemented here, like, I don't know really, but it's not finish, it's not treatment, but maybe you would have to incorporate a additional safety factor because of aerospace guidelines or so. You could do that with the KF factor here. So, yeah, this is also called the fatigue strength reduction factor, this KF. Okay, that's about it. And then we will hit close, and then we hit I'm not really sure about that one. Yeah, because I created that now, and now I'm not sure if it is that one. Load collector. pfat. To see that. Yeah, it's called load collector one. What a stupid name. But all right, my fault in this case. So close. And in the background, I'm 100% sure TCL commands gets just thrown at Hyperworks, and this will just create this property and with the material and stuff like that. All right, but we're done with that, so this should be all right. Now we can click on apply. And the next step would be the load case file. So now it's time to just simply load this load collector file to, sorry, I just have to put that into the folder I'm currently in. See that I will find it in an instant. Yeah, so right back with that. All right, so add by file. So you could also add the values here, but you don't want that. You want to add a file here. So I could just go here and select the load to CSV file. Should I give that a name? Yeah, LTH2. So this would be the one. And I just saw that there is a additional load one, which I should have guessed, but you would create that as well. So LTH2, I think H is for horizontal. I could plot it, get a feeling about what it is. Can I zoom here? No. Okay. Good. And then I will just save that. Now back to tutorial. I'm a bit lost. Sorry. I think I inputted the wrong file. No. No, it's all right. So I would have the other one, and this would be LTH1, also CSV. And that is good. Should I click import? Yeah. Yeah, but it worked on both occasions. Now, we did that. We plotted it. Now I think it's time to hit apply again. Next one. And here we have the load sequences. So in this step, one event consisting of 2 load time histories is created. Okay, in other words, the linear superposition of the stress caused by the 2 load time histories is requested during analysis. Using this event, one load sequence is constructed. Okay. They are superpositioning those 2 load time history series on top of each other, and that getting the resultant stress. Yeah, but this is, yeah, for me here the fun begins, where I'm not really sure what is exactly done. But I think this will just be added on top of each other. But yeah. So I clicked on add. For channel, select LT and L2, LT1 and LT2. Should I just control click that? Click that. Activate the radio button auto. Yeah, okay. And then single event. Should I hit this? Oh my god, this plus sign you cannot make out in dark mode. You cannot make that out. Ooh, that should be white. Or at least a different color. So yeah, this seems about right. So you created a new event, and this has one request. This has both subcases. Yeah, it's unfortunately different from that one. With the tutorial, 1 is to 1 and 2 is to 2, but I think that's all right. And then we can also scale it. So, okay, why is that? Set scale to 3. I don't know why, but I guess there's some reasons behind it. Maybe from the testing, maybe. Not really sure. But you could scale that and then save. And this is it. And that is it, right? So you can just save to close the window and create a fatigue event using selected subcases and channels. So I will just hit on apply. And I think now we are at the end. All right, so now we can just click here to save the FEM file. So I will just, should we name that? Yeah, we will just name it like that and make an extension with FEM. Yeah, we have that. And save it here. I think that's all right. Option is analysis. Could you also do optimization here? That's interesting. But I would not know how to do a optimization for fatigue performance. That would be really nice. All right, let's just submit the job and hope for the best that this will work. Yeah. Okay. We screwed up. So it says here error 6979 mat. You gotta be kidding me, right? Okay, I know what the error was, but did you catch it? No, the thing was that I did not click on the update button on this element and material, and I had a feeling about this in the earlier stages. Yeah, you have to close that. It's no way this is working. You must apply an empty frame or the what? You must apply an empty frame to the add panel command to run under Unity. Ah, what? Okay, forget about that. Let's clear first error here. Within elements and materials, you remember that we had this property thing here, and then we had this pfat. My God, now it's completely gone. But we had this pfat thing, and it's completely broken. Oh my God, what did I do? And this required that you created a pfat card, and this pfat card you could create, but it then was not updated or not assigned to the property, and I think that was the mistake. Now if I go to the property, there should be something with pfat or so. No? Well, actually I have no idea what it is then. Is it with the material? Is there something different? No, right? Matfat, that's the same thing. There's no pfat card reference or something like that. Maybe after all it was really the pfat card which needed change and wasn't changed, and it's not a card, it's a load collector. Anyhow, so we successfully run that analysis, and now I want to see the results. So how to do this? I will just create a new window here. This is more or less a session, right? Add page. Well, let's see if that works. I think, yeah, it should be Windows or so. So, yeah. So we have another page in the Hyperworks session, and this will automatically go to Hyperview. That's good. So I will now just simply load the fatigue results here, which are those. And I would expect to have counter values for damage. No? Okay. That's not so good. Let's go to results and see what subcases we do have. So we have two static subcases, and then we have the fat sub FPM tut subcase. And here we have damage. What a surprise. All right, so we can now plot the damage, which shows us now that the part is fine. So with that amount of damage, it's not really critical. But let's see what the tutorial says about this, to just have it completely here. So make sure the task post-processing is selected, fatigue analysis tree. Or we could have also got there with the fatigue process manager. All right, but I did it just manually, and that's also fine. For fatigue subcase, make sure select subcase is selected. For result type and data component, select the required data you want to contour from the drop-down menu. Load results, yeah, we did that, and that's the damage contour. So there's nothing more to it besides that. So yeah, my theory background is not that great into damage, but I know that a damage to the power of -6 is not that critical. So you would see now if there is a damage which is of interest, and you can also see on which elements this damage, these kind of damages are present. What I would suggest is, I don't know, but mesh quality? I mean, I really would want to have that with a finer mesh to be able to see more um, of the stress, to be just able to have more precise stresses. This is one thing I would comment on that, but sure, that's just a tutorial thing here. So pay in mind that the mesh should be good. I don't really know about singularities, but I think it should scale accordingly with stress, right? So if you have a stress singularity somewhere where you have a sharp angle or stuff like that, this will translate directly to the high damages, I would say, because it just sums them up, right? So, all right. Okay, that was that. What do you think about it? How did you see that with the process manager? It's definitely more easy to do it that way than to do it by hand. That's for sure. I just saw a bunch of fatigue models and there were so many cards. But I mean, in this case, it's not that many. You could have gotten to it with just doing it manually. But I think the process manager helps you a lot. But I'm curious about Hyperlife. Does Hyperlife do it even better, or is it just a process manager with a new GUI or so? So there's a lot of uncertainty at my point, because I didn't look into it until now. But I will do that in the future. So let me know what you think about it. Also, if you like it, please like the video, subscribe to the channel, leave a comment, whatever you like. And yeah, thank you for being here, for staying also that long in this topic. Yeah, which is quite tedious at times, but yeah, it's part of learning. And I think I know now a little bit more where I have to be careful. And just to summarize that maybe once more, is that you really have to look at each of the panels from panels of the steps from the process manager and be really sure what you're doing there. This will take time and you will make mistakes, as I did in the first try. So that's perfectly normal. Don't stress yourself too much, but just keep doing it. Keep doing it, and I will do that in the future with other tutorials and stuff like that. Also non-under videos, so I will not take everything to YouTube what I do in Hyperworks for sure, but just that you get a feeling how I would approach something like this. How to get good at fatigue analysis with Hyperworks in this case. All right. Thank you guys again, and see you later. Bye.